and welcome to the Chemistry channel. And today we're going to be beginning our discussion on thermochemistry. And we're going to be this video is going to be focusing upon the topics of energy, work, heat, and temperature. So let's begin by first defining energy. Energy is the ability of a system to do work or transfer heat. So what is work and heat? Well, let's begin by first talking about work. Work is the transfer of energy that allows an object to change its position. So work is the transfer of energy that allows an object to change its position. So in order to understand this, let's draw a little diagram. So imagine that you are pushing a box. And you're pushing the box along a wooden surface. And you're applying a force to this box, a force in this direction. If you're applying a force in this direction, you're causing the object to accelerate in this direction, so accelerate, and the box will move in this direction. So let's just say that the box starts at an initial position called xi, and you move it all the way to position xf. So you moved a certain object from position I to position f. In order to move this box from position I to position f, you have to transfer a certain amount of energy in order to allow the object to do so. And we can calculate this energy required to do this work from the work equation. So work is equal to the force applied on an object times its change in position, or the displacement. So work, this W stands for work, and the unit for work is a joule, and that's the unit for energy, and it's often symbolized by a J. F is the force applied on the object. And D is the displacement of the object. And the displacement is defined as the change in an object's position. So it's a change in the object's position. So in chemistry, we often talk about something called pressure-volume work, or PV work. So what is PV work? Well, let's first define what pressure is. Pressure is defined as the force exerted on an object per unit area. Therefore, the mathematical equation for pressure is P is equal to F over A, where F is the force applied and A is the area. So therefore, the units for pressure are newtons per meter squared. So that is pressure. So the equation for PV work, you can sort of understand where it comes from this little derivation. So let's start out with our regular work equation. Work is equal to the force times the distance. And we know from our equation here that P is equal to F over A. So if we solve for force, force is equal to P times A. So we can substitute this in to this term, giving us work is equal to pressure times area times D. Now these two terms, the area and the displacement, are units of length. So therefore, we know that area is meters squared and D, or distance, is meters. And when we combine these two together, you get pressure times meters cubed, giving us work is equal to P times V. So this is a little derivation just to understand where the P times V comes from. So now let's just show you the actual work equation for pressure volume work. So the actual equation for pressure volume work is dW is equal to negative P external dV. So dW is equal to negative P external dV, or the change in volume. Now you don't need to know for Gen Chem class the differential expression, or the differential equation. So let's integrate it for you to give you the equation that you need to know. So we're going to assume a reversible system, and we'll get into this in another video because you don't really need to know what this is for Gen Chem. So dW is equal to negative P dV, and we're going to assume constant pressure, because most chemical reactions take place under a constant pressure. And what this allows us to do is to take the pressure variable out of the integral. So when we integrate this expression, it looks something like this. So when we integrate this expression, you get the work is equal to negative P times the change in volume. And this right here is the important equation. So the equation you need to know. So this is the equation that you need to know for Gen Chem. And this is assuming constant pressure and it's also assuming a reversible system. So this is the equation that you will often use for general chemistry. So that is work. So let's now go into heat. So what is heat? Heat is actually very similar to work, and heat is the transfer of thermal energy from one object to another. So it's the transfer of thermal energy from one object to another. So like work, heat is just a transfer of energy. Work and heat are a transfer of energy. So in order to understand this, imagine a hot object. So I'll just do this in red. So you have a hot object. So it's hot. And then a cold object. So cold. Heat will flow from the hot object to the cold object, which makes sense. So this could be our heat. So thermal energy is transferring from the hot object to the cold object. So this is the direction of energy transfer. So heat flow is actually described by the Zeroth Law of Thermodynamics. So what is the Zeroth Law of Thermodynamics? So the Zeroth Law of Thermodynamics states that if A is in thermal equilibrium, so this means equilibrium, with B, and B is in thermal equilibrium with C, then A is also in thermal equilibrium with C. So this definition may seem a little confusing to you. So we're just going to use it by doing this by using pictures. So imagine once again, so I'm just going to copy and paste our hot and cold object. So let's copy and paste this. Okay, so let's just bring this down here. So we have our hot and cold object, and let's just say we put them together at time 0. So let's get my pen here. So time 0. So in time 0, the net direction of heat flow is this way. So heat flow is flowing in one net direction, from the hot object to the cold object. However, let's assume after quite a bit of time, so a long time, so after a long time, you'll notice that the two objects are the same temperature. So now they are the same temperature. So they're the same temperature. So what is happening? What is happening with the heat here? Well, the heat is actually in thermal equilibrium. So heat is flowing from this object to this object. Heat is also flowing from this object to this object. So basically, so let's just say this A and B, the rate at which heat flows out of A into B is equal to the rate at which heat flows out of B and into A. So this is what thermoequilibrium means. The rate at which heat flows out of A and into B is equal to the rate at which heat flows out of B and into A. So therefore, heat is basically flowing in and out at the same rate. And this occurs when these two objects are the same temperature. So quickly, let's define temperature. Temperature is defined as the average kinetic energy of the molecules in a system. So it's the average kinetic energy of the molecules in a system. So it's basically how much energy is in a system. So temperature is often measured in or in Kelvin. And now Kelvin, or K, is equal to the degrees Celsius plus 273.15. So you'll often see it either in Kelvin or in Celsius. So heat, the net direction of heat flow is from the object of higher temperature to lower temperature. So that is it for this video for today. And in the next video, we're going to be talking about the first law of thermodynamics. So I hope to see you all there, and see you next time.